Hello, today I'm going to discuss AI paper 3 November 2024. So let's start with question 1. In this question you will use graph theory and transition matrices to solve problems about a manager visiting 5 factories. Audrey is the quality control manager for a manufacturing company that has 5 factories A, B, C, D and E. She is planning a route to visit each factory once, starting and finishing from her home H. She determines the distance between each location in kilometers as shown in the table. So distances A to B is 100 km, A to C 150 km, A to D 70 km, A to E 50 km, A to H 40 km. Similarly, the distance is mentioned for B, C, D, E and H. So this is how you will read the distances between the two locations from the table. Now, Audrey wants to find an upper and lower bound for the shortest total distance traveled on a route. A. Starting at H, use the nearest neighbor algorithm to find an upper bound. So here we need to find an upper bound using the nearest neighbor algorithm. So in nearest neighbor algorithm we start with any vertex. Here they have already stated that start with H, so we will start with H and then you will keep on connecting to the nearest vertex. Okay, so let's start. Firstly we'll start with H. So H is my vertex, starting vertex, and then I will see the nearest vertex to it. So you just see the row of H. H to A distance is 40, H to B distance is 85, H to C is 160, H to D is 100 and H to E is 70. So you can see minimum out of these 5 is 40. So now firstly she will travel from home to factory A covering a distance of 40 kilometers. So here in this we just cover a vertex only once. Okay, once that A is covered over here, you can even cross this column. We will not consider this again now. Okay, next now from A you will see the nearest vertex again. So this is row A. From here you see the minimum distance. So the minimum distance is from H to E. Okay, so now from H to E it will travel 50 kilometers. Okay, now E is also covered. We'll cross that column. Now we will move on from E to the other nearest vertex. So I can see here that D is the one that we have not covered and that is at the least distance. So from E to D and it's covering 60 kilometer. Okay, then now D is also already considered, we can cut that. Now we will move from D to the other nearest vertex. So I can see here that is C, 90. So now from D we will move to C covering a distance of 90 kilometers and then now C is taken, we'll cross that. Now from C I will see the nearest, that is 80 towards B. So we'll move towards B covering a distance of 80 kilometer. Now B is also considered, we can cross that. Now only H is left, so from B it will move to H covering the distance of 85, because in this case in nearest neighbor we go back to the starting point from where we have started, so that is H. So this is 85 kilometer. So now in this case our upper bound is, you just need to add all the distances that we have covered. So 40 plus 50 plus 60 plus 90 plus 80 plus 85 kilometer. So this will be 40 plus 50 is 90, 90 plus 60 150, 150 plus 90 240, 240 plus 80 320, 320 plus 85 is 405 kilometers. So this is our upper bound that we have found out using the nearest neighbor algorithm. So this was all about part A. Now I will move on to part B. So to find a lower bound, Audrey uses the deleted vertex algorithm and deleted vertex edge. So in case of deleted vertex algorithm, we delete one of the vertex. Here they have already stated that we need to delete edge, so we will just delete edge. I will cross the row and column with edge because we are not taking this. So B first part is use Prim's algorithm starting at E to find the weight of the minimum spanning tree for A, B, C, D and E. You should clearly state the order in which the edges are selected by the algorithm. So here we need to find out the minimum spanning tree. So tree is that in which we don't have any cycle. Here we need to find the minimum spanning tree. So for that what we will do, we will take the edges with the minimum weight. Okay, and H is already deleted. So first of all, here you can see the minimum weight, the edge with the minimum weight. So if you see here, I can see that, and we need to start from E. From E we need to see which is the nearest vertex. So E to A is the least distance, that is 50. So first edge that we will take, let me write the edge here so that we have a proper sequence, and here weight. So we'll take E to A, and if you see the weight, that is 50 kilometers. Now again here we will not repeat the same vertex that we have already taken. Now we will take that edge connected to these two, any of these two vertex which has minimum weight. So if I see now, I have considered A. So even you can cross that. So we have taken A. Now we will see from E or either A, which one has the nearest vertex. So you can see here there is 70 in this case, and here we have 60. So we will consider the least one, that is 60. So now we will move on. Take the edge E to D with weight 60 kilometer. So D is taken, we can just cross that. Now we have 3, E, D and A. We can take any vertex nearest to them. So if I see E, lowest value here we have 120. For A we have 100. Then for D we have DC 90. Okay, so we'll consider this D to C with 90 kilometer distance. So now C is also taken, we'll cross that. Now we can take any nearest vertex from C, E, D and A. We can check. So if I see for C we have 80 to B, that is the least. Then if I see from E we have 130, that is more than 80. Then from, if I see from D, we have D2 that are already taken, 140, that is again large. So out of these three if we see, so we have 80, that is from C to B. So CB, that is 80 kilometer. We will consider that and we will cross B. Now here we have covered all the vertices, right? E also, A also, B, C, D, everything. So we just need to cover each vertex once, and we need to cover those edges having a minimum weight, and this is how we will apply Prim's algorithm. So here now minimum spanning tree weight will be weight of MST. I am writing for minimum spanning tree, 50 plus 60 plus 90 plus 80 kilometer. So that is 50 plus 60 is 110. 110 plus 90 is 200. 200 plus 80 will be 280 kilometer. Okay, so this is how we apply the Prim's algorithm. Okay, here as we started with E, so E was already taken, so that's why it's just left, or we should have cut it in the beginning only. Okay, so now B, second part, they are asking us that this was the first part. Second part is hence find a lower bound. So how we found lower bound? We just add the weight of two minimum edges that are connected to H that we have deleted with the weight of minimum spanning tree. So weight of MST plus two edges with minimum weight. So I think here H to A is 40 and H to E is 70. We will take that H to A, that is 40, plus H to E, that is 70. So that become 280 plus 40 plus 70. So 320 plus 70 will be 390. So this is the lower bound. I'm just writing it with LB. So here what was it? It was weight of minimum spanning tree plus the weight of two edges with minimum weight and connected with the edge that we have deleted, that was H here. Okay, so I hope that it's clear. Now we will move on to the next. Now here, after initial visit to all factories, Audrey now decides she will visit one factory each day. She decides which factory to visit according to the following transition matrix. So this is the transition matrix that they have given. After visiting factory D, there is a probability of 0.4 that Audrey will visit factory C next. Write down the values of P, Q, R. Okay, so first of all, this is a transition matrix. This is 2, because you can see here the sum of column is 1. So this is from 2. So here they have given that after visiting factory D, there is a probability of 0.4 that Audrey will visit factory C, right? So it's from D to C. So from D to C, so here our P will be 0.4. You can just directly write 0.4 because that is already given, that from D to C it's 0.4. Next, Q we need to find. So for this we will use column 3. Sum of it we will just put equal to 1 because it's the sum of probability, that is equal to 1. So 0.1 plus 0.2 plus 0.2 plus Q plus 0.2 equal to 1. So 0.2, 0.2, 0.2, that is 0.6 plus 0.1. So 0.7 plus Q is 1. So Q will be 1 minus 0.7. So Q is 0.3. So Q is also done, that is 0.3. Now we need to find R. So we will be using column 4, sum equal to 1, same concept. So 0 plus 0.2, P is 0.4 plus R plus 0.2 equal to 1. So R plus 0.4 plus 0.2, 0.6 plus 0.2, 0.8 equal to 1. So R is 1 minus 0.8. So R is 0.2. So this is how we got all the three values of P, Q and R. Okay. So next, Audrey first visits factory A. Write down the initial state matrix. So first she visit factory A, so probability for A will be 1 and rest others will be 0. So in this case, steady state S0 column vector will be 1, 0, 0, 0 because she is visiting factory A. So probability will be 1 for that and 0 for rest other. Okay, so this is our initial state matrix S0. Now, second part, they are saying find the probability that the fifth factory that Audrey visit is C. So initial is first one, for that we have S0. So in general we write Sn is equal to Tn times S0. Okay, So where n is, like here they said that the fifth factory. So fifth factory, first was S0, so fifth will become S4. So our fifth factory, that is S4, and according to the formula here just substitute NS4, so it becomes T4 times S0. Okay, T is the matrix that they have already given to us. How you will find T4? You will just plug in the matrix in your calculator, raise it to power 4, and you will get the answer. I'm writing here the matrix so that you can check your answer. So it's 0.1025, 0.1832, 0.2162, 0.2513, and 0.2468. So I have also calculated this using the calculator. You will also use that because you will be allowed with the calculator in paper 3, and you can easily find the values. 0.11065, 0.1868, 0.2197, 0.23855, 0.2443, then 0.1047, 0.1898, 0.2266, 0.2348, 0.2441, 0.1009, 0.1912, 0.2282, 0.2354, 0.2443, 0.1021, 0.1946, 0.2334, 0.2263, 0.2436, and S0 is 1000, column vector 10000. When you will multiply, you will be getting a column vector that is 0.1025, 0.1832, 0.2162, 0.2513, and 0.2468. This is your S4. Okay, so it's just a normal matrix multiplication. So here now you can write the probability fifth factory that n to visit is C. That will be, so probability fifth factory is C is equal to, you can write down the probability for C. This is for A, B, C. So that is 0.216. That is up to, I have approximated up to 3 significant figures. Okay, first one for A, second for B, third for C, fourth for D, and last one for E. Clear? Okay, now third part is find the probability that the fifth factory that Audrey visits is same as the second factory that she visits. Okay, so we have already found out S4 for the fifth visit. So here for third part we would require both fifth visit and second visit. So I will, for second visit I will find S1 basically. So second factory visit S1 I will find, that is T times S0, right? I just plug in here N as 1, so it becomes T1, that is T times S0. So that will be equal to, again similarly you will perform the same calculation. T, you know the vector that is already given to us, PQR we have found out already. S0 is 1000. So when you will multiply it, you will be getting 0, 0, 0, 0.7, 0.3. So probability for A, B and C is 0, just we have for D and E. So here, according to the question they have asked, that find the probability that the fifth factory that Audrey visit is same as the second factory she visit. what we need to do, we just need to multiply the probabilities here. So it's 0 into A for fifth into A for second plus A for second visit for B times fifth visit for B. So we have probabilities for them. So for ABC it will be 0, then 0 times 0.2162 plus 0.7 times 0.2513 plus 0.3 times 0.2468. Okay, so all these calculations you will be doing using the calculator, so you don't need to worry about it. So ultimately here when you will multiply, it will be 0.250. Okay, because they are saying same, second and fifth is same, so we will just multiply probability for of fifth visit for A into probability of second visit for A plus for B, C, D and E, and that's how you will get the probability. Okay, so let's move on to the last E part. So over a long period of time, find the probability of Audrey's visit that are to factory A. Right. So they are saying over a long period of time, and they have given us a vector transition, matrix T, in that we have a probabilities of visit. So over a long period of time, so what you will do in this case, you can just find a large power of the matrix, like T to the power 50, let's suppose you can find, because steady state means after some time the answer that you will get after multiplying T with itself, it will come out to be same, approximately same. So here I am just taking T to the power 50 here. Okay, and when you will find out that, so you will be getting the same values, and I'm just writing here the values for that, and you can also check, you will get the same column. So in that case we will just write the answer, whatever rows, whatever repeated values you are getting. So I'm just writing steady state vector as equal to 0.104. I have approximated it up to 3 significant figures, 0.190, then 0.226, 0.235 and 0.244. So this is the steady state vector. Steady means same, so means after some powers, higher powers, when you will multiply the matrix with itself, each column will be same. Okay, then second, find the expected distance Audrey travels in a day, given that she always travels directly from home to a factory and then back to home. Okay, so here we need to find the expected distance. So as she will go and come, so distance will be counted twice. So I will already write 2 times, and how we will find that, we will just multiply the distance into probability. So let me write expected distance in a day, that is equal to 2 times, because she will cover the same distance when she go and come. So probability we will be using for the steady state, because she's coming and going expected, so when it become constant, the probabilities are same after some stage, so we will be using that. That is the steady state probability. So for A, it's 0.104, and it's expected when she traveled directly from home to a factory and then back home. So we will be looking into the distance from H to A, right, because we are considering home. So just see, from H to A it is 40. So what we will write, 40 into the probability 0.104 plus, then from H to B, if you will see, that is 85. 85 times probability for B is 0.190. Then we will see for C, that is 160, So it become 160 into 0.226 plus, then distance to D is 100 into 0.235 plus, then distance between home to E factory is 70. So 70 into 0.244. So when you will calculate this, you will be getting 194 kilometers in 3 significant figures. So this is the expected distance that she will travel in a day. So that's all for this question. I hope that it is clear to you. Thank you. Hi, today in this video I am going to solve question 2 from paper AIHL paper 3 November 2024. So let's start. In this question you will first consider a statistical model for the number of fish caught in a lake and then consider a differential equation to model the growth of fish in the lake. Althea enjoys fishing in a lake near her home. She usually fishes for 4 hours each day and she records the length of each fish before releasing it back in the lake. Althea decides to perform a chi-square goodness of fit test at a 5% significance level to determine whether the number of fish caught can be modeled by a Poisson distribution. Then she uses her records from the last 50 days to produce this table. Number of fish caught per day 0, 1, 2, 3, 4, 5 and greater than 5. Frequency 2, 7, 12, 11, 10, 8, 0. A is calculate the mean of number of fish caught per day. A, mean. So for mean, let's just take the number of fish. Let's name it as x. So capital X equal to small x. These are the values for the variable x. Then small f for frequency. So if I just write down the formula in terms of f and x, so that is sum of fx divided by sum of frequency. So you will just multiply x with the frequency and add them. 0 into 2, 1 into 7, 2 into 12, plus 3 into 11, plus 4 into 10, plus 5 into 8. Rest others are 0. So it will not affect the mean. Divide by sum of frequency 2 plus 7 plus 12 plus 11 plus 10 plus 8. Now when you will just multiply it and add, you can use the calculator because you will be allowed with the calculator for paper 3. So you can use that to do all the calculations. If you will add the frequency, it will come out to be 50. If you will add the numerator, it will be 144. So 144 divided by 50, and when you will divide that, it will be equal to 2.88. So our mean here is 2.88. Okay, so we are done with part A. Now we will see part B. For part B, they are saying, hence, calculate the expected number of days in a 50-day period that Althea would catch no fish according to the Poisson model. So here x will follow the Poisson model with lambda that we have already found out in A part, our mean, that is 2.88. Here we are required to find probability x equal to 0. Okay, so here you should be aware about the general formula for the Poisson distribution that we follow is lambda to the power x e to the power minus lambda upon x factorial, where x is following Poisson distribution with the parameter of lambda. Okay, here lambda is 2.88, x is 0, so you will just substitute that in the formula and you will get lambda to the power 0 e to the power minus lambda whole divided by 0 factorial. So anything to the power 0 is 1, 0 factorial is also 1, so you will be just left with e to the power minus 2.88. Again you will just directly use your calculator to find the value of e to the power negative 2.88. Okay, and you will get the answer. So negative 2.88 is 0.056134.8. I'm just taking more significant figures. because ultimately I need the answer for expected number of days. So I want more exact value for that. So I will take more number of digits after decimal. So expected number of days will be, you just need to multiply total number of days times the probability that she catches 0 fish on the number of days when she catches 0 fish. So 50 into probability we have above. So you can just again plug in into the calculator and multiply the value of probability by 50 and you will get 2.81. So finally you will write the answers in 3 significant figure, but in middle if there is some calculation you can take more digits. You should take more digits so that you get the more accurate answer at the end. Okay, so this was for part B. Now we will move on to other part. Althea calculates the expected frequencies and record them in this table. Number of fish caught per day less than equal to 1, 2, 3, 4 and greater than equal to 5. Expected frequencies are 10.9, 11.6, 11.2, 8.05, 8.25. Okay. Now in C they are asking explain why Althea has combined the columns for 0 and 1. So here in this chi-square the expected frequency should be greater than 5. So if it is less than 5 then we combine the columns. So here the reasoning will be to ensure the expected frequency is greater than 5. Okay. So we need to combine the columns if the frequency is less than 5. So that is the reason for part C. Now next is D. For this chi-square goodness of fit test, first write down a suitable null hypothesis. So if you see the question, what they said, determine whether the number of fish caught can be modeled by a Poisson distribution. So here our null hypothesis, that is H naught, will be the data can be modeled by a Poisson distribution. So the data can be modeled by a Poisson distribution. This is our null hypothesis according to the given statement of the question. Okay. Now second part, they are saying write down the number of degree of freedom. So we have a formula for finding the degree of freedom. So I am writing here df, degree of freedom, we write with number of categories minus number of estimated parameters minus 1. So here in this case if you see, number of categories are 1, 2, 3, 4, 5. Number of estimated parameter is 1 because we found out mean in part A, minus 1. So 5 minus 2, that is 3. So this is our required degree of freedom. Next, find the value of P. Now you will be using chi-square test. From the calculator you will just use chi-square goodness of fit test, sub in the values of expected, observed, degree of freedom and you will get the value of P. Okay, you just need to plug in the values and you will get the value of P, that is in this case 0.843. This I have found out from calculator. Okay, 0.843. Now fourth part, write down the conclusion justifying your answer. Now we need to conclude as they ask us to find at 5% significance level. So 0.843 is greater than 0.05. Okay, our p value is greater than 5%, that is 0.05. So there is insufficient evidence to reject H naught. So there is insufficient evidence to reject H naught. Okay, what does it mean? That means data can be modeled by a Poisson distribution. Okay, distribution, because that's what we considered in the null hypothesis H naught, that the data can be modeled by a Poisson distribution, and there is insufficient evidence to reject that, so that means it is modeled by a Poisson distribution. Okay, so that's all for this video. We'll continue in the next video after this. Hi, in this video I'm continuing question 2 part E. So let's read the question. A factory is built on the edge of the lake and Althea is concerned about the impact of pollution on the length of the fish. Based on her records before the factory was built, the length of the fish could be modeled by a normal distribution with a mean of 50 centimeter. After the factory is built, Althea collects a random sample of 15 fish, so means n is 15 here, and calculates that mean is 48.6 centimeter and Sn minus 1, that is the standard deviation they have given, that is 2.56 centimeter. Althea decides to test if there is sufficient evidence of a decrease in the population's mean length. The hypotheses for her test are, they have given H naught as mu equal to 50 and H1 as mu less than 50. Perform the test at 5% significance level to show that there is evidence of a decrease in the population's mean length. Okay, so now here they have defined the null hypothesis, they have defined the alternate hypothesis, they have given you the standard deviation, mean, n value. So you just need to substitute all these again in your calculator, and you need to just put mu less than 50 for H1, and then you will be getting the p value as 0.0263. This we got from calculator. Okay, then here now we will compare it with the 5%, that is 0.05. So 0.0263 is less than 0.05, so there is sufficient evidence to reject H naught. Okay, because it's lesser, so here there is sufficient evidence to reject H naught. Okay, that's what they ask us, that to show that there is evidence of a decrease in the population's mean length. So if we are rejecting H naught, means we are accepting the alternate hypothesis in that mu is less than 50, so it's decreasing. Fine. Okay, now let's move on to the next one. Althea now decides to consider the length of an individual fish in the lake as it grows. She researches the von Bertalanffy growth model, which states that dl upon dt is equal to k times L infinity minus L, where L is the length of fish in centimeters at time t in months since birth. L infinity is limit t approaches infinity L, the length the fish approaches at it as it grows. K is a constant. Justify your answer. First is state whether K is positive, negative, or could be either. So as they have given us dl upon dt is equal to k times L infinity minus L. So the sign for k will depend upon dl upon dt and L infinity minus L. Okay. So now if you see here, dl upon dt, change of length with respect to time. So it's a length, it will be positive, right? It can't be negative. Okay, and next L infinity minus L, where L infinity means that when t is increasing, then what is the length, how it grows, so it's also increasing, right? So if you will see the difference, larger value minus the smaller value, it will also be positive. So if both are positive, so that shows that k will also be positive. Okay, so here k is positive. Second, we have that state that value of dl upon dt as t approaches infinity. So we will be using this equation for finding the answer again. So as they are saying that t approaches infinity, so t approaches infinity, t is becoming large and large, so our length will approach L infinity, right? Because limit of t approaching infinity L is L infinity, so it will approach L infinity. So that shows that L infinity minus L will approach 0, because the difference will approach 0 as the values are becoming same. So that shows that dl upon dt will approach 0 as t approach infinity. Here we are talking in terms of limits, that's why we are putting the arrow. That means it's going closer and closer to the value, it's approaching that. Okay, now third part, state a parameter in the model that could have been affected by the factory pollution in the lake. Okay, so we have a length, we have k. Okay, we need to see what all will be affected in this case. So obviously our length will decrease when there is a population, it will affect the length. So L infinity, that will be affected because since the length will decrease. So as the time increase, our L infinity will be affected because length will decrease because of the pollution. This is the first one. Also K will be affected because it will not grow so quickly because of the population. It will not growing as quickly, okay, as it was possible. So R2, L infinity and K both will be affected. Two parameters will be affected because the pollution will affect the length. So then if it affects L, it will ultimately affect K. Okay. Next part is at t equal to 0, a fish has length L0 centimeter. G, sketch a graph of dl upon dt against t. You should label the coordinates of any x-intercepts and the equation of any asymptotes on your sketch. Okay, so we need to draw a graph, and equation we have dl upon dt is equal to k times L infinity minus L, right? So let me just write it down. dl upon dt is equal to k times L infinity minus L. And in case if our t is 0, so dl upon dt when t is 0 will becomes k times L infinity minus L naught, because then L become L naught. So this is our value for dl upon dt, because they have given t is 0, then L is L naught, right? Okay, so let's just draw the sketch. We'll be taking the x's, we'll take x-axis as t, y-axis as dl upon dt. So the graph will be dl upon dt versus t, right? Okay, now here when t is 0, we got the value of dl upon dt, right? That I wrote down here, k times L infinity minus L naught. So somewhere here it will be t0, and this value will be k times L infinity minus L naught. And as the growth will decrease, so our graph will go somewhat like this towards, and our asymptote here will be dl upon dt equal to 0. This is our asymptote. Okay, yeah, so that's how we draw the graph, decreasing graph with one y-intercept and one we have here horizontal asymptote. Okay, fine. So yeah, that's all for this. We have marked all the asymptotes and intercept. Now let's see the next part. Solve the differential equation dl upon dt equal to k times L infinity minus L using the initial condition. Write your answer in the form L equal to f of t. So we need to solve the differential equation. So let me write it down. dl upon dt is equal to k times L infinity minus L. So here we will just separate the variable L and t. So dl upon L infinity minus L will be equal to k times dt. Then we will integrate both sides. Okay, so on right side the integration is easy. K is a constant, it's just integration of dt, that is t. But here we have dl upon function, so you must be aware about the formula that we used in integration. Oops. Integration of 1 upon f of ax plus b, or we can just write the linear function ax plus b. We know integration of 1 upon x is ln mod x plus c. So here now we will use the integration of ax plus b, that is ln mod ax plus b upon a plus c. So we will always divide by the derivative of this function. So derivative of ax plus b is a. Similarly here we are differentiating with respect to L. So here it become ln mod L infinity minus L. So L infinity is just a constant, L is a variable. So the derivative of with respect to L we are doing L infinity minus L will be minus 1. Okay, because L infinity is a constant, L is a variable. So we divide by minus 1 equal to k times t plus c. So this is what we get after integration. So here now I can just shift this negative sign to other side so that it become easy for me to simplify. L infinity minus L is equal to minus kt plus c. Now I want what they ask us. They ask us to write L equal to f of t. So I want L. Now there is ln. In order to get rid of this ln, we will apply exponential both sides. We will raise to power e both sides. So this become equal to e to the power minus kt plus c. Why? Because a to the power log a b is b. So base of exponential and log should be same, then it's just b. Ln means base e, so it will just come out to be L infinity minus L, and that is equal to, so you can even remove mod because this will be positive value. L infinity is greater, right? So it will be positive, and I will just separate the powers here. I will write e to the power minus kt, e to the power c, and we can just write e to the power c as some k, because the e to the power c is also constant and capital A is also constant, right? Now we need to use the initial condition to find the constant. So we know that when t is 0, L is equal to L naught. So I will just substitute that above. L infinity minus L naught is equal to a times e to the power 0. So anything to the power 0 is 1. So that means L infinity minus L naught is equal to a, our constant. Now you will back substitute that value in the equation above here. This you will substitute here. So you will get L infinity minus L is equal to L infinity minus L naught times e to the power minus kt. So I want L as a function of t, so I will keep L on one side and shift others to other side. So minus L is equal to minus L infinity plus L infinity minus L naught times e to the power minus kt, or I will just multiply the equation by negative sign. So L infinity minus L infinity minus L naught e to the power minus kt. So this is how we got L as a function of t, because L naught, L infinity, they all are constant and t is the variable. So this is our final answer for part H. Okay, fine. So here we used some rules related to the logarithm, okay, because log ln was there, and ultimately we get the answer for this. Okay, so that's all for this question. I hope that it is clear. Thank you so much.